Hey everybody, this is Andrew with Avarso ASAP, and today we're going to be talking about transformations and translations of functions. Now this topic has a wide variety of applications, everywhere from art to engineering to medicine, and today we're going to explore that. For today's lesson, you're going to need the following materials. You're going to need a notebook, something to write with, and then also it would benefit you to follow along on Desmos, and we'll include a link to that in the description below. Before we begin talking about transformations and translations of functions, I thought it would be good to discuss parent functions. So for the first one, we have the parent function for all linear functions, which is just f of x is equal to x. Another way you may have seen it before is y is equal to x. And so I want us to keep in mind this idea that f of x is actually equal to y moving forward. But then, moving on, we can see that we also have quadratic functions, cubic functions, absolute functions. So take a minute, pause the video if you have to, and really just familiarize yourself with all of these parent functions. All right, so now we're moving over to Desmos, and if you haven't done so already, you should open that up in a browser of your own. And you'll see here we have two functions that are clearly related to some of the parent functions that we had just been looking at, but I want you guys to pause the video if you have to. This is a do now for you guys. And I want you to describe the transformations that have been applied here. So take a minute, do that for yourself, and if you can, even write out that function and how its transformation looks. All right, so now that you've hopefully done that, let's move on. So we'll look and we'll say show list, and we'll see here that, okay, let's look at the green function first. So the green function is actually, its parent function is the absolute value function. So if you got that, congratulations. I'll notice that it's actually shifted up by 1 unit, and we can zoom in here, we can see that more clearly. But so we'll see that it shifted up 1 unit, and then you can notice it has a slope of 3. So we include that in its transformation. So it's shifted up 1 unit and its slope changes by a factor of 3. So let's take a second now and let's look at the parabola. Same thing as ever, but it's shifted over 2 units to the right and 1 unit down. So we want to reflect that accurately in our equation. And we'll go over that in a second, but just so you guys could see, here are our functions and here are the new equations. All right, so the first thing we'll be discussing in this video are vertical shifts, which are just a translation up or down. So let's start out with our parent function, all right? So our parent function is going to be f of x, and we're just going to use that as general notation. F of x, it can be any function. Let's not worry about it. So to shift something vertically up, so if we wanted to shift something up as opposed to down, we would say f of x plus some constant c. And again, c is just the common notation for a constant. So f of x plus c will give us a vertical translation up. If we wanted a vertical translation down, then c would be negative, or another way of writing that would be f of x minus c. And so we can see that there. So this is how it would be algebraically. Now let's take a look at how it would be graphically. So here we have the absolute value function, and now if we want to shift it up, we simply say plus 1 or 2 or 3 or however far we want to shift it up. And if we want it to shift down, we say minus 1, 2, 3, however far. All right, now that we've seen this done graphically, let's take a look at an example. So here we have f of x is equal to x cubed. So if we wanted to shift this up by 5 units, how do we do that? Take a minute, pause the video, try it for yourself. So hopefully you've done that, and now we'll see that this is actually just f of x plus 5, which we can then rewrite as x cubed plus 5. And there we have our answer. That's our new function, and we can plug that into Desmos, and we'll see that it gives us the correct answer. All right, so we've done vertical shifts, but now let's talk about how to scale something up. So if we wanted to scale something vertically, and by that I mean either we're stretching it or we're going to be compressing it. So if we wanted to scale something vertically, how would we do that? And let me just type that. So vertical scaling. So if k is less than 1 but greater than 0, then this will actually be a vertical compression. But if k is greater than 1, then we will have a vertical stretch. And so let's actually look at that graphically now. Okay, so now that we've learned how to scale our functions vertically, let's take a look. So here our parent function is square root of x. So if we wanted to scale this vertically, let's say by a factor of 2, we would just simply add 2 in front. And then we'll see that while the parent function is at 1, 1, once we multiply it by 2, it becomes 1, 2. And then at 4, it's 4, 4. And so this is completely consistent with what we would expect. All right, so let's discuss horizontal shifts now. So horizontal shifts, what we're going to do is we're going to take f of x plus c. So now you'll notice that we're actually adding c to x instead of to f of x or y. So we have f of parentheses x plus c. And one thing to keep in mind is that when c is greater than 0, we're actually shifting our function over to the left. And when c is less than 0, we're shifting it over to the right. Now, we'll discuss this in greater detail as we show this graphically, but I want you guys to think about it and take a minute, pause the video if you have to, but try to consider why this is the case. All right, so now that we've seen this graphically, let's try an example of our own. So let's say we wanted to shift a function, the absolute value of x. Let's say we wanted to shift this over to the left by 3 units. So, all right, 3u to the left. All right, so take a minute, pause the video, try to see if you can do that on your own. Hopefully you've done that. So let's take a look at this together. So we'll take f of x, but we notice that we're shifting it over 3 units to the left. So if we wanted to shift something to the left, c has to be positive. So we'll say, oh, this is x plus 3. So we have f of x plus 3. Now if we wanted to write that as an absolute value function, we would see that this is the absolute value of x plus 3. All right, so we've discussed how to shift a function horizontally. Now let's demonstrate this on Desmos. So here we have our function f of x is equal to the square root of x. So if we wanted to shift this to the right, what we would do is we would say minus 1. Now, why is that? Let's think about this. It's because when x is equal to 1, in this case, it's the same as when x is equal to 0 in the previous case, right? So I'll put over here square root of x. And so if we have x is equal to 0, well, we want this to be over 1 unit now, right? So we'd have to set an equality. If we want both of these, if we want the square root of x minus 1 to be equal to 0, then x must be equal to 1. All right, so now that we've discussed how to shift a function horizontally, let's discuss how to scale a function horizontally. So take a minute to kind of guess how this is going to go down. Otherwise, just let's get to it. So we're going to actually multiply x by a scalar k. So instead of multiplying k to f of x, we're going to be multiplying it to x itself. And one thing to keep in mind is that we still have these conditions over here, just as we did for vertical scaling. So when we have k between 1 and 0, we're actually going to be compressing our function horizontally. So that leaves us with when we have k is greater than 1, and we're actually going to be stretching our function horizontally. And we'll see that in greater detail as we move to Desmos. So we have x squared, and now we have something that we'll mess with on the bottom. So let's say we wanted to compress our function by a factor of 1/2. Let's say we want our function to complete or to reach its y value in half the x value. So all we would do is we would just say instead of f of x reaching 1 when x is 1, now we have f of x reaching 1 when x is 1/2. And that's really because of the scalar there. But let's say we wanted to stretch our function by 2, then we would just do 1/2. And now it's the same reasoning. The scalar is affecting our x value. So now for x, if we want 1/2 x to be equal to 1, x must be equal to 2, and therefore f of x is going to be equal to 1 when x is equal to 2. So there you have it. All right, so now that we've seen how horizontal scaling looks graphically, let's put both horizontal shifts and horizontal scales together. So let's take f of x is equal to x cubed. Why not? So we're going to have x cubed, and let's say we want to shift it over 3 units to the right, and let's say we want it to be stretched by a factor of 3. So we want to stretch this by a factor of 3. How would we do that? So let's write that down. We have 3 to the right, and then we have 3 stretch. So 3 stretch. So let's consider this. One other thing to consider is that when we're both shifting our function horizontally and scaling our function horizontally, we're going to need to change the constant that we're adding. So here, let's take x squared, and let's say we want to shift it over 3 units to the right. So we'll do minus 3. But let's say we also wanted to change our scale. So let's say we wanted our function to be compressed by a factor of 2. So we would say 2x minus 3. But now you'll notice that our function is no longer 3 units to the right. It's actually only 1.5 units to the right. And that's because when we've changed our scale, now x only needs to be equal to 1/2 to be the same value as when x was equal to 0 for our parent function. So we're just going to need to apply a similar change here. So instead of 2x minus 3, now we would say 2x minus 6. So another way of looking at that would be, so we'll take x squared, but now we'll say 2x minus 3 squared, just like that. So we've discussed vertical shifts and scales and horizontal shifts and scales. So now let's talk about flipping across the x and the y axis. And this is actually very simple. So for the function x squared, and this is actually a poor example, so let's use x cubed. So for x cubed, we'll notice that it's not a symmetrical function, right? So that means that if it's positive, it does not equal the same as when it's negative. And let's go over. Okay. All right, so now that we've discussed horizontal shifts and scales and vertical shifts and scales, let's talk about flipping our function across the x and the y axis. So it's actually pretty simple. Here we have, let's take this as f of x. So x cubed will be our parent function. If we want to flip this across the y axis, we will simply add a negative sign in front. So in this case, if we were trying to scale it vertically, it would be with a negative k. So negative k gives us a flipped function. And so if we wanted to scale this, if we wanted to flip this parent function, x cubed, across the y-axis, it would be negative x cubed. And if we wanted to scale it by a factor of, let's say, 2, we would say times negative 2x cubed. And you'll see that now we have negative 1, 2, and that is the same as, all right, so here, all right, so now that we've learned about horizontal shifts and scales and vertical shifts and scales, let's talk about how we're going to flip our functions across the x and the y axis. So actually, let's use the square root function. All right, so now that we've learned about horizontal shifts and scales and vertical shifts and scales, let's discuss how we're going to flip our function across the x or the y axis. So here we have the square root of x, and this will be our parent function. So if we wanted to flip our parent function across the y axis, what we would do is we would simply add a negative sign in front of it. So now we get negative square root of x. If we want to flip this across the x-axis, however, we would apply the negative sign in front of the x. So this would give us, as you can see, this would give us a completely different function. And so now we flip this across the x-axis, and now we can flip it across the y-axis by, once again, removing the negative sign. And we can do this again and again and again as much as we want. So that's all it takes to flip a parent function or any function across the x or the y-axis. So the lesson portion of this video is concluded. So now let's practice. So here we have 4 different problems that I want you guys to try on your own. So we'll go over these at the very end of the video. But for now, take your best shot at it. So pause the video, give it a go. All right, so here we have our first solution. As you can see, we shift it over to the right by 8 units and down by 3 units, which is entirely consistent with what we would have expected. And then it should be horizontally stretched by a factor of 2 and vertically stretched by a factor of 3. So hopefully you described that, and hopefully you got that equation. So now we have 2 cosine of 2x plus 2. And so as you can see, we shift our function up by 2 units. So, and also we vertically stretch our function by 2. So we can actually apply these transformations real time. So we have cosine of x. So now we have 2 cosine of 2x, or 2 cosine of x. Now if we add that 2, we'll see that it actually compresses by a factor of 2, and now we can add 2 and it'll shift up. So just like that. Then we have 1/2 x minus 4. So this is just the absolute value function. We shift it to the right by 4 units, and then we compress it vertically by 1/2. So that's all that's going on there. And then finally, we have the square root function. So because we have this negative right here, this negative 2, we're actually going to flip it across the x-axis. So we can see that there, and we're also going to want to vertically stretch it by a factor of 2. So we're going to stretch it and flip it at the same time. And then this x minus 1 will give us a shift to the right by 1 unit. All right, everybody, that's it for today's lesson. So we should have learned how to shift and stretch or compress a function horizontally as well as vertically, and also how to flip a function across the x or the y axis. For additional practice, we've included a link in the description below, so be sure to check that out. Also, please share this video with your friends, and if you haven't already, make sure to subscribe to the Abarso ASAP channel. This has been Andrew, and I'll see you next week.